Yeah, I'm Mark McNally. I'm the Advanced Technology Demonstration Team Senior Manager. Yeah, I lead the overall project containing the sort of 12 partners from across the industry. We have 8 sort of industrial partners, ourselves, and 3 academic partners. Well, in terms of capturing the overall support from the 12 partners, what we've managed to do is not only deliver innovations for each of those technology platforms, we've also identified spin-off opportunities that we're now going to take forward as part of the project. The main activity within that is to make a significant change to CO2, improvements with the more stringent legislation coming through within Europe, China and the US. So each of the propositions have been tailored towards those markets. So for instance, the mild hybrid is tackling the challenges around high volume vehicles within Europe. The plug-in hybrid is around the challenges around China, and the full electric vehicle is tailored towards the US market. Not exclusively, but effectively those are the requirements that we've laid down for the 3 products. I think there's been a great deal of benefits. We certainly see the challenges and the sort of appetite to deliver those 3 products from all of the partners. I think there's always a refreshing sort of attitude from the team, very passionate, but also you can see the collaboration, the sort of partnerships and the strengths within those partnerships moving forward. It will be far beyond the Evoke project.
Designing electrical machines does require a number of different disciplines. So electromagnetics, mechanical, thermal, and this group is quite a niche group. It brings academia together with industry in the UK. So we get experience in the construction of electrical machines through Zytec. We get design flair from universities such as Bristol and Newcastle. We get the mechanical side from Tata Steel, looking at how do we best make use of the materials for the right design and the right application. So having them all together in a room, working on a particular design, getting the best out of them it's been a fantastic experience from that point of view. But managing it all and making sure it keeps going in the right direction and not going off in a tangent is also another challenge.
It's really nice as a university to work with a company. They're able to give you a detailed specification of what they want and then follow that the whole way through the design process. So we've been involved in everything really. We've designed the electromagnetics, so that the innards of the motor. We've also designed the whole mechanical system of the motor, and this motor is also a little bit special, which in that compared to other motors that are in cars today, it's quite high speed. And so trying to design a motor which is very high speed means that there are big challenges in terms of just simple things like bearings in the motor. The motor is going on a Land Rover. Land Rovers are well known for going off-road and wading through deep water. So we've also got to make the motor waterproof. And those are just some of the mechanical challenges. It's been fantastic to be involved all the way through that process and then see what we've designed and then being involved in building actually get built into the final car that you'll see at LCV.
So I think one of the great things about the Innovate UK-based project is that you get to know some of the leading players in industry, and you understand what their needs are and their constraints in a way. And it gives us a future focus of areas that we might want to invest ourselves in future research. In university we tend to kind of drift into very much problem-based, science-based explorations. And it's really helpful to understand the more real-world aspects of how the technology is exploited and used in a bigger, wider system.